So good evening everyone. Welcome to today's webinar. I'm Uma. I'm part of Acsia HRT. I'm really excited to be hosting this session today. So first of all, would like to take you through our video which will help you to understand who we are and what we do. So in the current scenario where the automotive industry is on a progressive approach towards the future, we are well into it. In a nutshell, this is Acsia. We drive the future of vehicle experience. So I'm pleased to introduce you today our speaker, Mrinal. Mrinal is working as an AI specialist in Acsia. So talking about Mrinal, he's an expert in deep learning. He's an expert in deep learning and holds a strong root when it comes to knowledge in programming languages like C, C++, and Python. He's one of the strong hands behind our AI-based driver monitoring system. So before I hand over the session to Mrinal, I have few points to cover about today's presentation. First of all, today our webinar will be available live on Axia's YouTube channel. So we would love to hear from you during today's presentation. So if you have any questions for our speaker, feel free to type it through the Q&A tab. We'll be answering the questions at the end of the session. For the YouTube viewers, you can post your questions in the comment section. So make sure you are connected to our social media pages, Instagram, YouTube, LinkedIn, so that you don't miss any of our updates. So without further delay, I would love to welcome our speaker. Mrinal, over to you.
Thank you, Oma. A very good evening to everyone. I will be taking a small session on the introduction of machine learning and artificial intelligence. So let's start from where it all began, the history of AI. At the beginning of 1950, John von Neumann and Alan Turing did not create the term AI, but many of the scientists as well as researchers believe that the Dr. Alan Turing has created it. They just made the transition from computer to decimal logic. Turing also published one paper on computing machinery and intelligence. In 1956, Dr. McCurdy, who is also often known as the father of AI, has termed the artificial intelligence. And AI at that time was developed on the LISP programming language, which became important in machine learning. Let us check the evolution of the AI. In 1950, again, Dr. Alan Turing published a landmark paper in which he speculated about the possibility of creating machines that can think. In 1951, Christopher Strachey wrote a Stricus program and Dr. Prince wrote another program for chess. In 1956, scientists and researchers believe that this is the year of the birth of AI, and John McCarthy has coined the term artificial intelligence. In 1959, the first AI lab was set up in MIT, named as AI Lab. The research started to begin on the year of 1959. In 1960, first robot was introduced to General Motors assembly line. And in 1961, the first AI chatbot called Alexa was introduced. And in 1997, IBM Deep Blue beats the world champion Gary in the chase of game. In 2005, Stanford racing team autonomous robotic car was introduced. And later on in 2011, IBM's question answering system LIT has came. Now let's come to the application part of the AI. As we all know, every day in our daily life, we use several applications of AI, starting from Google AI to services like Uber, speech recognition, self-driving car like Tesla, Autopilot, GM Super Cruise, then Blu-ray technology, IBM Watson, Amazon recommendation, and Netflix. These are all the applications of the AI we use regularly. On the right-hand side of the screen, shown the implementation in the different sectors. If I start from the banking and financial service, I think many of you know that the HDFC Bank uses customer support based on AI, and also Amazon also uses such type of AI systems. And in manufacturing department, many robots are used in production line. And in travels, I think during a flight, more than 50% of the pilot uses autopilot during the whole flight timing. And in the healthcare, as you all know, what our world is suffering right now due to the huge pandemic of COVID-19. And researchers are trying very hard to use AI algorithm to detect if a person has a COVID-19 symptoms from the lungs X-ray. So these are all the applications of the AI. Let's go to the deep of AI. That is the stages of AI. Basically, there are three stages of AI: artificial narrow intelligence, artificial general intelligence, or we say as a deep AI or strong AI. And last is the artificial super intelligence. Let's look into the ANI, that is artificial narrow intelligence. It is designed to perform specific task, or you can say as a single task. There are lots of example, and in our smartphone we use regularly such type of things like Alexa, Siri. These are all the voice assistant or speech recognition uh, systems. They are used to do specific task it is programmed to do. Now let's come to the AGI, that is artificial general intelligence. It is also known as a strong AI, or you can say the deep AI as mentioned. This concept of machine with general intelligence that mimics human intelligence and behavior with the ability to learn and apply its intelligence to solve any problem. AGI can think, understand, and act in a way that is indistinguishable from that of a human in a given situation. AGI is a stage in the evolution of artificial intelligence where machine will possess the ability to think and make decisions like us human. I think many of them knows about the Sophia, but it is still in the developing stage. We can't consider Sophia as a artificial intelligence, general intelligence system. But I think in the upcoming days, we'll definitely take as Sophia as a AGI system. Now, the artificial super intelligence, it is yet to be developed, but it is a stage of AI when the capability of the computers will surpass human being. So I think Stephen Hawking also mentioned it into his books. Now it's still on the science fiction books. In upcoming century, I think it will be definitely be implemented. So these are the stages of AI. Let's come to the types of AI. There are four parts or types of AI. First is reactive machine AI. Second is limited machinery memory AI. Third is theory of mind AI and self-aware AI. Reactive machine AI is based on the present data. This type of system basically works on the present data, considering only the current situation. I would like to give one example of IBM Chase, who has beat the world champion Gary. And when it comes to the limited memory AI, this type of AI has a short lived or a temporary memory that can use to store past data and hence evaluate future action. I think everyone has heard about self-driving cars. These type of cars have limited memory AI that uses data collected in the recent past to make immediate decisions. Now the theory of mind AI. This is a more advanced type of artificial intelligence. This category of machines is speculated to play a major role in psychology. This is yet to be happen. A lot of research is going on in this area. And the last is the self-aware AI. This have their own conscious and become self-aware systems. This is still yet to be developed, and most of the things are on the paper right now. It is not been implemented. Now let's come to the machine learning part. and where it comes from, what is machine learning. Let's to the machine learning part. The first question arises into our mind is, where does this machine learning comes from? It is a branch of AI, or we can say it is an application of AI that provides system the ability to automatically learn and improve from the experience without being explicitly programmed. I want to highlight one point, that at the last line it is written as without being explicitly programmed. What this does it exactly mean? Like I want to give one basic example to understand the term and also the importance of the machine learning as well. Suppose uh, one day you went to a shopping for apples. The first thing after going to the market, you will search for the apples and you will choose the best apples. Before that, I think there are some rules and points there will be there in your mind before buying. That is, which one of the apple is the best? How will you choose it? So these are the point. I think it will be there in your mind. That is, first point, it will be red and bright apples are sweeter and they will be good than the pale ones. Second is small and pale are not so much sweet. That is there in your mind. And green apples are tastier than red ones. And there are other lots of points which will be there in your mind before choosing or buying the apples. Now, suppose if I tell you that these are the rules you will choose before buying apple. Now, try to write a code for it. I think most of the listener who are listening are coders or programmers. Like when you're ending up writing the code for this choosing apple, you will end up writing a lot of if and else conditions, I believe. But every time you make new observation about the experience, you may have to modify the rules and you have to similarly make the changes into your code also. Suppose you have seen less amount of reddish apple. So you need to put that also into your code. So every time you see new observation, you need to put into your code. And the if else condition will be more and more into your code. And what will happen? The complexity of the code will increase, definitely. So it is very difficult to manage and add all the new features inside this if else condition. Now, suppose if I ask you to write a similar code for choosing oranges instead of apple, so what will happen? You will again change the condition. You will change again the if condition that instead of red or green, you will change to the orange. So it is very difficult to add this type of features into your code, and it will increase the complexity of the code as well. And that's where the machine learning comes into play. So below there is a flow chart, or you can say the flow of the learning process of a machine. How a machine learns, starting from the data. Data plays an important role in the machine learning. On the next part, training the machine with the suitable data, appropriate data, and selecting a model, building a model, and the final stage is predicting the output. So this is the complete learning process of a machine, how a machine learns. Now, I guess you have understood what is the need of machine learning with the example what I gave with the apple and oranges. Now, next slide, I'll be going technicalities of for need of the machine learning. The first is the increase in data generation. I guess everyone knows that nowadays we use minimum of uh, like hard disks or hard drive, minimum of 1 TB. So due to this excessive production of data, we need a method that can be structured or analyze or draw useful insights of the data. This is one of the part we need, why we need the machine learning. Other part is improved decision making. Several ML algorithms can be used to make better business decisions rather than humans. And when it comes to the uncover patterns and trends in data, finding hidden patterns and extracting key insights from the data, where the machine learning comes into play. And from building self-driving cars to detecting genes, ML can solve any type of complex program. So here it comes when it comes to the complex solving complex programs for the machine learning. Now let's go deep into the learning process, starting from the define objectives. So when you will build a model, first thing is the requirement or what type of model you will build. So this is a define objective. Then after the objective, you need to gather the data. What data, what type of data or how you will gather the data. I think every ML developer or every ML or AI specialist has like faced a challenge in this data gathering or data search. So first thing you need to do is how you will get good data. And the next is data preparing, that is also known as data pre-processing part. Then data exploration, then comes to the building of model. If I go clockwise of this figure, then building a model is very important because you need to choose the correct parameters, features, and you need to build a very good model, very accurate model. And the next thing is the model evaluation, testing the model. This is nothing but testing a model. And after that, prediction comes. Once the model is ready, you need to evaluate it, and then after some improvements, finally you need to make prediction. So this is a complete flow of machine learning process. In any type of machine learning, you need to follow this process. So let's check the types of machine learning now. What are the types of machine learning? Basically, there are three types of machine learning. One is supervised machine learning, one is unsupervised learning, and one is reinforcement learning. On the right hand part of the screen, you can see a figure which shows the different subtypes of machine learning and their application on the top layer. First, I will start from the supervised learning. Supervised learning are of two types, is again classified into two types, that is classification and regression. And on the top layer, you can see the application, that is forecasting. This is nothing but weather forecasting, or and other is prediction, new insights. So these are all the application. When you go to the part of classification, the applications are fraud detection, what nowadays what different banks are using online payments. For online payments, this fraud detection is used. Then image classification, then customer retention, diagnostics. So these are all the application on the top layer of as you see on the classification part. Now if I come to the unsupervised learning, they are also classified into two types, that is clustering and dimensional reduction. Many of the unsupervised learning uses clustering, and it has a huge application. I think everyone has heard of target marketing, what Amazon, Flipkart does, and other applications are recommended systems, customer segmentation. And the application of dimensional reduction is structure discovery, feature elicitation, meaningful compression, and big data visualization. So these are all the applications of supervised and unsupervised learning. And let's come to the reinforcement learning. This is a different type of machine learning. The applications are the robot navigation, skill acquisition, learning task, game of AI, and real-time decisions. So let's go deep and know that what is supervised learning and how it works. So supervised learning is a technique in which we teach or train the machine using data which is well leveled. As you can see, there is the image of a apple, and below that it is labeled as apple. And it is given as input to the model, and the model at the output, it predicts that it is a apple or not. And if you give different types of data, suppose you need to predict with what type of fruit it is, if you want to create a model like that, you need to put different type of images of maybe oranges, banana. I need to level that data, that okay, this is a banana, this is a orange. And when you will test the model, when you will give a new input, such as you give a different image of apple, So module will automatically generate the output that this is apple. So this is a very simple concept of supervised learning. Here, the important part is the data. How you are giving the data. You need to label the data and you need to filter it well so that the model can predict accurately. So next, we are going to the unsupervised learning. This type of model, what it does, it search for a pattern. The unsupervised learning involves training by using unlabeled data and allowing the model to act on that information without any guidance. Let's go to the previous slide. Here, the guidance is the label. That is, you are labeling it that these are apples. But in unsupervised learning, there are no such type of guidance or labels is required. And we use unsupervised learning when we have uh, we have not much data. In that type of cases, we use unsupervised learning. Here, what it happens, you give input data like apple, mango, and other banana, orange, maybe other different fruits. What it will do, the model will try to search a pattern in that data, and it will just separate it from each and one another, as you see in the screen. So this is the overall structure of unsupervised learning. Here, we have to keep in mind that we don't need any labeled data here. But in supervised learning, we need to have a labeled data. Now let's come to the reinforcement learning. This is quite different from supervised and unsupervised learning. In supervised learning, it is all about the making decisions in sequential order. As you can see, there's a complete flow chart starting from input, then response, then feedback, then learn, and then input. So here, what it happens, the input acts like an agent is pardon, an agent which is put in an environment, and he learns to behave in this environment by performing certain action and observing the reward which it gets those actions. So this type of learning works in a reward system. Suppose if I give input as apple, so what will do, the system will tell give a response that it is a mango or not. If it is not a mango, or if it is an apple, it will say no, wrong, it is an apple. And on the later half, the machine learns and it stores the data that okay, this is an apple. And when you give a new input, machine can automatically predict that okay, this is apple. So this is the overall structure of reinforcement learning. And as on the first slide of the different types of machine learning, I have told the several applications, like it is used in robots and different other applications also. Let's check what is the difference between supervised and unsupervised learning. The supervised learning needs a label data, and the whole process is a type of feedback mechanism. Suppose when you are building a supervised model, what we'll have to do, you have to put a set of data and you have to train the model, and at the end you need to evaluate the model. So after you evaluate, you can check that what is the accuracy of the model. And if you think that it is not enough, it is below, the accuracy is not so much good, you need to add more data as 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 per the prediction or as per the accuracy. So it's a complete feedback system. And here data set is the most important role which plays in this type of learning, that is supervised learning. And when it comes to unsupervised learning, there is no such labeled data and there is no such feedback mechanism used. It only search for the hidden structures in the data. Now these are all the machine learning algorithms which commonly used in these three types of learning, that is supervised, unsupervised, and reinforcement learning. There are another types of machine learning that is also called semi-supervised learning, that takes the algorithm of somehow of supervised as well as unsupervised. It comes in between of supervised and unsupervised. So on the further sessions, we'll be having a complete discussions on this different types of algorithms, that is linear regression, logistic regression, decision tree, random forest, k nearest neighbor, and naive Bayes. So let's look at which algorithm are used in which type of machine learning. So here's the complete flow chart. If I start from the left hand side, that is supervised learning, that is regression, that is linear regression or regression is used in supervised learning, and polynomial regression as well. Decision tree, random forest, these all algorithms are used under supervised learning. And if it comes to the other part, that is classification part, naive Bayes, SBM, that is support vector machine, the decision tree, KNN, these are all used under supervised learning. And if we go to the unsupervised learning, there are three other algorithms used, that is clustering, association analysis, and hidden Markov model. Under clustering, there is VDPCA, K-means. These are all the algorithms used under the unsupervised learning. And in reinforcement learning, I missed out one point in reinforcement learning. That is, there are also types of reinforcement learning. What is negative reinforcement learning and is positive reinforcement. On the on the further sessions, we'll be discussing all about this. What is negative reinforcement? What is positive reinforcement? And now there at the prediction layer or the output, the supervised and unsupervised, you will get two types of output. One is continuous output, one is categorical output. So the further sessions will definitely define, or we'll discuss all these terms and all these algorithms. That is linear regression, what is linear regression, how the decision tree works, what is random forest, classifications, everything we'll be discussing on the further sessions. For now, thank you from my sides. If you have any questions, you can ask. And now over to Uma.
Thank you, Mrinal. We'll go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the Q&A tab. So we have our panelists, Vipul and Chetan from our AI time. So we'll try to answer as many questions as possible. So for the rest of the questions, we'll try to get back to you over email.
Yes, actually, do we have any AI-enabled infotainment system? One question came from Girish Chandran. So it's like we have an AI-enabled infotainment system. That means the infotainment system is capable of monitoring the driver and things like that. So that is an AI-enabled system that's available here. So one question from KV Subhash. How AI is connected to automotive and how can mechanical engineers take advantage of it? So AI is actually more used in the manufacturing part of automotive than what you see right now. So most of the people might not know about the internals in the manufacturing area. I can quote one example like this. In the General Motors use AI actually for designing the seat belt, and it actually resulted in getting a seat belt which is actually 40% lighter and 20% stronger than the original design that is designed by the humans. Do you guys use Genevi or AutoSAR? Actually, we use AutoSAR in our development. How machine learning is useful for mechanical engineering? Actually, I think I've answered that question to you. What are the current main uses in the automotive industry which uses AI and machine learning? How mature are they? Yeah, that's a good question. One part of the question I have answered, that's in the manufacturing area. It's being used and it is pretty much mature. And the other part, the self-driving area. Actually, Google Waymo has actually achieved a level 4 plus category. So that means it's much mature in that area too. And some other areas like uh, driver monitoring or drive and path the perception area. So these areas are actually very much advanced. So they are very much mature, that I could say.
I got a question from, I think, Cjo Lewis. What is inference AI? Is it a part that you have already explained? No. I think on the later further sessions we'll be discussing all this topic. So you need to stay tuned on into our YouTube channel. I think we'll definitely discuss all this part on the later sessions. Thank you. And Christiana Antoni has asked which language is best for the AI. Now Tesla has used, there are several frameworks available for like PyTorch, TensorFlow for AI development or machine learning development. So you can use this type of frameworks. It is available in Python also. There are several frameworks like PyTorch. Tesla has already implemented using PyTorch framework. I think I have answered your question as well as Chetan has answered. I don't know the name, but he asks that where should we start from if we want to learn ML? If you go through our sessions, I think you can start coding in several APIs after you go to a certain level. I think you can start it from very beginning, like what is machine learning, what are the types. You can start from there only. And if you have a very good mathematical background, I think it will help you a lot in going further. Thank you. There are lots of questions coming. One is Krishna, Venkata Krishna. Is there another type of machine learning? There are, as I mentioned, that yeah, there is another type that is semi supervised learning that comes between the supervised and unsupervised learning. So on the later sessions, we'll discussing all these things. No need to worry about it. Okay. I don't know the name. It's showing as 1+6. Please mention your name. That will be helpful. Okay, you have questioned, are the AI in the mobile phone camera really capable of scene detection, and how truthful they are? Scene detection. Like scene detection means what? I think our panelists can answer this better. I'm not getting these questions.
Yeah, in the mobile camera, we have a option called scene detection. That means whether the scene is in indoor, whether it's a outdoor scene or scenario or something. So these are actually pretty much effective, but depends upon the implementation that is done already in the different mobile phone applications. For example, OnePlus has got good accuracy, and for the Oppo, I think Oppo also is having the similar kind of accuracy. What should you do? To connect mechanical engineering and AI after mastering AI, could you please give us an example? Okay. So one example I already told, that means it's already used in the manufacturing industry. So if you are heading for the manufacturing industry, you will be having exposure to the AI enabled. But it's not directly as a mechanical engineer with the AI is not that promising, but you will have an exposure to AI. Even if we say artificial and artificial intelligence and automotive can we completely remove all human intervention. That's actually the ultimate goal. That means the level 5 autonomy is actually aiming for completely removing all the human intervention in the driving area. So that will come in other areas also. So most of the tasks most of the tasks which is kind of tedious for the humans will be taken over by the AI. Can AI be dangerous? If they think like human. Yeah, that's a question from fiction. So can that's cannot be treated as answering it straight away.
And many books in science fiction, they have mentioned that maybe AI can be dangerous. I think time will say.
Yes.
Here is a question: how do the data for automotive AI is collected? So I would like to answer that. Like, it depends on the problem, what like the solution what we are giving. If it is a image based, it would be usually from a series of, like, it will be from a collection of people with different diverse images. And if it is about something like for the autonomous vehicle we need of roads, so it would be again images, and it depends basically on what sort of uh, data we want for a problem. So it is not specific that we do it from this for automotive. So even there we'll have so many different problems which has to be addressed by AI. So it will be specific to each and every solution.
Tesla uses AI for auto drive. Is it possible to hack into? Does that make it vulnerable? One question from Abhijit NS. Yes, it is hackable. That means they are actually, and the automotive company is actually having invested heavily on the automotive security, so that these are to make it more not hackable. But still, as if in any other application, this will also have some vulnerabilities. So it can be hackable.
I need to answer, I think, Ananthuraj questions. Will neural networks deployed in the car like Tesla, which depend on road signs and marks, ever become reliable enough to work in India? I think now I don't think we have a quite of infrastructure in India to implement such type of thing. In upcoming, like which in upcoming days maybe, like many cities, high tech cities can implement like Bangalore or other cities which has some infrastructure. They definitely can implement it. What the
I think most of the questions are answered. One or two questions are pending.
I want to answer Divya KR question. What are the applications of AI in infotainment system? Lots of applications are there. In Suppose when you are hearing a song, recommendation comes of the specific song, that is a part of AI only. And there are other lots of, when you're going into a Play Store or any other such type of apps to download, many of the apps which comes into recommendation, all the recommendation process is based on AI. So this is a part of infotainment system.
Yeah, one question from Nikhil. Autonomous driving is based on learning on traffic signals, road patterns, etc. Isn't it possible to misinterpret such a system with false data? Sure, it is actually possible. Actually, actors are coming with more innovative ways to hack what all things that we are representing. So, in the coming days in the future, this will be non-hackable or less prone to all these mm, effective ways of hacking.
I'd like to answer Girish Chandran. Uh, Also, how the integration done with AutoSir. Acsia has a specialist team on which is working on AutoSir. I think I will take this question, and if you provide me the Gmail, our AutoSir specialist will definitely get back to you.
So Girish's questions is actually related to AutoSAR only. So we will get back to you, Girish, from the AutoSAR experts. Steven.
I would like to answer this from Vishnu Ji Nair. What are the application of ML in agriculture field? So for now, which is prominently openness of the cultivation, and like you might have seen, there are so many videos on YouTube which you can see. One which of I'll explain. So in some Western countries, there is a farm which grows capsicum, which will be cultivated, like it is harvested from a AI machine which has been trained how to understand what only capsicums to harvest. So that is one of very good example or application of ML in agricultural field. And there are so many research going on to make these like the to genetically kind of modify these agricultural things so that they'll be kind of immune to some of the pests or some kind of disease which comes. So that is also very active research things going on. So I think I've answered part of your question.
I'd like to answer Amal Dev question. Is Sophia a fully developed humanoid robot? Still now it is in a developing stage, as I mentioned. It is not yet fully developed. It is on the developing stage. I think in this year or on this later on this year you will get some news about what is the stage of the development. Still it to be developed a lot.
The thoughts on using Java for ML. Most of the ML and for ML it's okay. For the deep learning part, most of the libraries will be is actually coming up with Python and C++. So we prefer Python or C++ for the deep learning development. Java is also okay. That means it's not that much up to date with the latest technologies.
think I would like to answer a part of this question from Girish Chandran. Um, I'll take a part of this question. Whether he just want to know the things what goes into autonomous driving level 3, which we have developed. So DMS, what we have developed, which is part of ADAS, it is actually a part of autonomous driving level 3. So, and it consists of so many other modules, other features. So it is a part of autonomous level 3 as well.
Add to that, it will be available up to level 4 DMS.
Hello. Actually, I think we are running short of time. So great. I'm happy to know that you are really interested in AI and ML. So thank you, everyone. We appreciate you being here. For more updates on the upcoming webinars and updates on the latest automotive technologies, follow us on LinkedIn, Instagram, and Facebook. So thanks again for joining us today. So we'll see you next time. Have a nice day.